Gotta get things just right, you know? All right, so who finished doing all the labs? Mackenzie, nice. That's more hands than I expected. All right, did you guys like do labs about closure, that kind of stuff? Yeah, so today is gonna be kind of like yesterday's lecture where it's gonna be like, look at these cool things about JavaScript, but instead of overwhelming you with all the cool things about JavaScript, it's gonna be more focused and it's gonna be like, look at this cool thing about JavaScript. So it's like one of my favorite lectures. I really like this one. It covers closure. We're gonna go into higher order functions, pure functions, basically what makes JavaScript JavaScript, why it's functional. We're also gonna do a little bit of DOM manipulation just because it's necessary to sprinkle it in here and there because you're gonna be working with it more. And we're gonna watch a funny video if we have time, but even if we don't have time, we'll probably still watch it. All right, so who can tell me what makes JavaScript functional? Because functions in JavaScript are like first-class objects. So what does that even mean, that JavaScript is functional? Gavin? Like, what can you do with functions in JavaScript?
You can return functions within a function, declare functions in a function, use functions with each other.
Okay, those things sound a little bit vague. Can be more specific. There's some answers up here. So what can you do with functions? What's the idea of callbacks? We talked about it yesterday. Who can tell me what a callback is? Kat?
It's a function that you can pass into it.
Exactly. So you can pass it in with the idea of like invoking it later instead of invoking it right away. What about this iffy thing that we talked about yesterday? What is that? Jackie, do you know?
Something with immediate, like you have a function.
Exactly. Well, it's like as you're declaring the function, you can invoke it right away as you're declaring it. And we're going to touch on that a little bit more. Functions can return other functions. We've seen that yesterday. And then there's something inside of objects that we can do with functions. One of the labs mentioned it. Does anyone know? So we have like our key value pairs. Do you know, Andy?
Are you getting at like how we can have private variables for objects, like an ID?
Not really that. It's just that inside of objects, you have your key value pairs, and values can actually be functions in JavaScript. So that's another cool thing you can do. And then when it comes to JavaScript, it's important to expose you to the idea of like imperative versus declarative. It's a slight distinction. Maybe employers might ask you, what is imperative versus declarative programming? So does anyone know the difference between imperative and declarative programming? If you don't know the answer, there's some ideas up there. Do you know, Danny?
No. Alright.
All right, so imperative programming is like when you tell your program step by step how you want it to run its code. Like if this, then do this, else do this. You have like iterate here and you're telling it step by step how to do what you want it to do. And that's basically all we've known so far. And then with declarative programming, you just tell your program what you want, and it's up to the program to figure out how to get it. So you might see like more returns when it comes to JavaScript. The cool thing about JavaScript, it gives you the option to write imperatively or declaratively. So when you see declarative JavaScript, you're usually focusing on what things return. So an example, there's like a Medium blog that I looked up. This is like an imperative way to write something. So you're telling it step by step how to run its code. You're making a for loop. And then the declarative way is just like a one-line thing. You're like, return this. So this is something you'll get exposed to more. It's a very slight distinction. We've also dealt with some languages that are more declarative. Does anyone know what those are? Can you think of a language that we've written in that tells your program, I want this, without telling it how to get it? Gavin?
SQL.
Exactly. SQL is declarative. Anything else? Another example is CSS. CSS is a very declarative language. You just tell your program, I want this. I want the background color to be red. And it's up to the program to figure out how to do it. So that's the idea of like imperative versus declarative. Not something you need to get hung up on, but just keep it in the back of your mind as you deal with JavaScript, especially going into React. Because with React, you're going to be dealing with like putting components on the page, and it's going to be very much, I want this. So that's kind of that idea. What about pure functions? What makes a function pure versus impure? Hugo?
That everything is the same thing every time.
That's very key. So every time you give it the same input, it's always going to produce the same output. Anything else? What is this idea of side effects? What are side effects? Steven, do you know?
Things your program do that you don't expect it to do.
It's,
Things you don't
yeah.
want as a result.
Things that are outside of your return statement. Sometimes you do expect it to do that and you're telling it like, I want to change this thing, but side effects are basically changing things outside of just the function you're working in. You're like changing other variables. It's something to do outside of what you're returning. So even console logging is considered a side effect. So that's kind of interesting. Anything else? So another big thing about pure functions is we don't want to rely on the same variables. So we don't really want to rely on global variables as much. We want pure functions to be self-contained. Because when you're relying on global variables, sometimes you're also mutating those global variables, and that gets kind of messy. So we don't want to mutate things. We don't want to share variables with like other functions. We just want to keep our function self-contained, and we want it to like return the same thing every time we give it the same input. So let's write an example. But first, who can remind me how to link a JavaScript file to an HTML file, and what's like the fastest way to make a template here? We went over this yesterday. Gavin?
HTML tag.
All right, cool. What should we give our headline today?
James JavaScript.
That's the same as yesterday, guys.
No, initially it was James JavaScript lecture. This is just James JavaScript.
Fine. So it
James.
is. All right, sounds good. Where should we put our script tag?
All the way at the bottom.
Totally.
Not all the way at the bottom, but like, you know, towards the bottom.
I know what you mean. You mean in the body,
Yeah.
right? But below everything else.
Yeah.
All right, so let's do that. And we went over this yesterday, so we're not going to spend too much time on it. Let's get rid of some of this stuff that we don't know what that does. And which file are we linking?
The JS file.
Exactly. Oops, it's not going to work. All right, so let's just test if it works. All right, so this is linked up. Now we can put JavaScript here and we can play with it on the front end. So what we're going to do is we're going to write an impure function, and then we're going to show some examples of like how to make it pure. So we're going to start with an array. Global variable, already kind of like, uh-oh, right? And we're going to write a function called doubler that doubles everything in the array. So what do you think this function takes in? It takes in an array, right? And so say we want to go through this array, write a basic for loop. What do we want to do?
What are we trying to do? We're trying to double, like the value within the array.
So we want to turn each thing at that index into the double of itself. And we want to return the array. So let's test it out. We have a variable called array. It seems to be working, right? But what happens if I invoke it again? What do you think the output will be? Yeah. So this kind of breaks this pure function idea, because for the same input, we're now getting a different output every single time. So how can we fix this? How can we use a different kind of array?
You just slice it versus you copy it.
Exactly. So you can make a copy of it. So we can make like a copy. And how would I use slice on this? And then what? Will this work?
You have to reassign array in the
Mm-hmm.
in the copy.
Oh, okay.
So this one
And
and this one
Any of
Yeah,
the,
length as well, right?
I think, yeah.
and this one.
Okay.
Does this one really matter though?
no, it's the same.
Exactly. So just think about those things, like it's going to be the same length. This one doesn't matter. We can change it to copy. That's fine. What are we returning? All right. Let's check it out. So now it's actually giving us the same output every single time. So did you guys notice I used const here, but then I'm still manipulating this array? This is kind of like a point I didn't bring up yesterday. Does anyone know why this still works?
But it's not working, right?
It's working. It works.
It's only, wait. I don't understand. Don't we want it to be doubling?
It is doubling.
But only one time?
That's what we want.
Oh, okay.
So when we give it the input of this array, we want it to double. Every time we give it the input of this array, it doubles. Hugo?
But it's not changing the original array.
It's not changing the original array, exactly. Yesterday we talked about const versus let. A little bit, not in too much detail. What's the difference between const versus let? Alex?
Sorry, I'm not going to talk about the difference between const and let. I'm going to talk about why I think this is working.
Alright.
And it is because that was yesterday. This is.
All right.
How do you know? Because I wasn't here.
He knows because he wasn't here.
So I think it's because you can change the value of the variable, but you cannot reassign accounts, right?
Exactly. So spot on. With const, the only thing you can't do is reassign the thing that you assigned. So I can't be like copy equals something else. But what it's an array, I can still mutate that array. I can still change the individual values like I'm doing here, even though I'm using const. I can also push on it. That's fine too. So like, for instance, if I chose to do this with an empty array, and for each thing, I pushed into the empty array, this should still work. Like I can still push into the array and mutate things. Let's just verify. Yeah, so it's fine. What's some other ways of copying an array? Let's go back to this idea. So we know about slice. And what's the problem with copying versus not copying? Like, why can't they just do copy equals R?
Destructive.
Exactly. Gavin?
Can you spread the array into another array?
It's my favorite one. How do we use the spread operator?
Dot, dot,
All right. Dot, 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 what?
dot. Array.
Do I need anything else? Yeah. So what the spread operator does is it like spreads out your array into individual values, and then you put brackets back around it. So you're like, hey, get back in that array. So that's what the spread operator does. So you can do it this way. Just to make sure it works. I like to test everything. You guys know me by now. But the other cool thing about the spread operator is you can put in extra values if you wanted to. So let's experiment with it a little bit. New tab, always new tab. So what should I put in my array? I want to put some students. Who wants to be in this array? Steven does. Who else?
JavaScript boy.
Gavin. Gavin boy. Who else?
Oh, JavaScript boy. Oh,
All right. All right. One more. Come on, one more volunteer.
Andy for sure.
Okay, so we have this array. We have this students array, right? So if I want to make a copy, I want these to point to the same, like if I make a new copy of this array, I don't want it to point to the same reference as this one. That's what we discussed yesterday, right? Like if I were to just make a copy and set it to array, they're going to point to the same reference, and like pushing into one affects the other. That's a problem. So we use our spread operator, which we already talked about. But the cool thing about the spread operator is you can put more values in here. So it'll take this whole array and add other values onto it. So let's add some more students. Let's add Kat. Who else? Jackie. So you can do stuff like this. You can even put some values in the beginning too. Mackenzie. Who else? Jordan. So now our copy has everyone. And it has the array that we started with. And we're able to put stuff before and after it. So like the spread operator is really freaking cool, and you guys should totally use it. I didn't get how to use it for the longest time, and I'm like, oh, this is really cool. All right. Let's see. What about using map? Can we use map to do this function? I want to rewrite this function using map. How do I do that? So like the reason map is really cool is because it's not destructive. It already gives you a new copy. So we can just, instead of doing all of this trash, we can just do map. I'll start you guys out. r.map. What does map take?
Function.
All right, it takes a function. What does that function take?
It takes a variable.
Give me a name of a variable.
Andy.
That's not a useful name.
It's a horrible name.
What does this variable represent? All right,
So each
LM. It represents the element in the array. Great. Then what? How do I finish out this map?
Are we still trying to do the same thing?
We're trying to do the same thing as above, but using math.
Return element.
Do we need this return?
Nope. Yes.
No.
I would like to say yes, but the safe answer.
How's this?
You think that's the safe answer? You think no is your ally? What happens?
Alright, so you do need to return. So.
Where?
Return array now,
Here?
Oh, yes.
Why?
because it's JavaScript.
Who knows? It's JavaScript, right? Okay.
Semicolon.
Otherwise, the question is not returning.
Honestly, I got lazier as I started using JavaScript. I don't really use semicolons anymore. I think like as you start out, you should definitely use semicolons. So PSA announcement, use semicolons for now until you learn how to be comfortable and like know where they go. Then you don't have to use them as much. But there are times where not using semicolons, you will run into issues, and that has to do around arrays. Like sometimes if you have an array on the next line, it might think your previous line, you're trying to read some kind of attribute because of like the square brackets. And that's when you run into problems when you don't use semicolons. So PSA over with. What's going on now? Why is this happening?
You still need the return of the function,
Which function?
the callback function.
So this function?
Yeah.
All right. So, good rule of thumb, when you have a function, make sure it returns something. So this outer function returns something. This map takes a function, so since there's a function right there, you should return something there. So how can we make this function in the arrow notation, ES6, to like shorten this? Andy?
You can just write EL, and then arrow.
All right.
I'll erase the return, and I return the bracket.
Exactly. So if you want, like, when you have a one-line function, you don't need the curlies. You just need the arrow. And when you leave out the curlies, that means you're trying to return. So you can do this. Can we shorten this further? Can we turn this whole thing into one line?
Yes, you can.
How?
Let's go.
Let's use const. Maybe that'll make things a little bit easier.
Can we just do it if
Why?
it's a one-line callback?
There's another way. I don't think an iffy would work here. I've started you guys out. It would be similar to this. So what do I need to do? So remove this and this. Yeah, so you can do that. That still works. Now we're getting more to this idea of declarative programming style in JavaScript. So we went from something like this to something like this. Pretty cool, huh? All right, so enough about this stuff. Let's talk about copying objects. Say I have an object. Who wants to be my example here? Gavin? Let's do Matt. Matt's not here. We can talk about him. All right. What kind of properties go on Matt? Name, Matt. Personality. Let's describe Matt in one word.
Fine.
Funny? All right. One more property. What else?
Occupation.
All right. What's his occupation?
TCA.
All right, cool. So I want to make a copy of Matt. How do I do that? Can I just do this? All right, we all know the pain now. We all know you can't just do that. So how do I do it?
Spread operator, man? No,
Why no?
because it's not an array.
You can use it.
It is.
Pretty cool. So this is Matt. This is copy. If we compare them, they're not pointing to the same reference. So this is good news. We've successfully copied Matt into a copy. The other cool thing about the spread operator is we can do something similar that we did in the terminal. We can add extra properties too. So, what kind of property do you want to add to Matt? Age? Do you guys know his age?
24.
45.
We'll put 24. All right, so now our copy is a copy of Matt and it has an extra property. What happens if I change his occupation? Or like if I put occupation here, what would happen? Who thinks it will overwrite this?
Not bad, but copy.
Yeah, so copy will have occupation overwritten by the new thing. So spread operator, pretty useful. There's another one that's not a spread operator. It's called object.assign, which you're going to see pretty often, especially when you work with like React and Redux. Does anyone know how to use object.assign to make a copy of something?
Just put the bracket. No, what's it called? Parentheses.
Where? So how do I start out?
You start with the parentheses and then you do the object assign parentheses again, I think. And then
This is extra. This is a little extra, guys.
alright. And then you need the object what is it called? You just put it in curly braces.
So curly's. All right, what arguments does object.assign take? Why am I giving it this thing here?
The curly braces means that it's a new object.
Yeah, this is a brand new object that we're gonna copy stuff into. It's the best practice to start off with like a fresh slate, and that's where you're copying things into. What about the next argument of object.assign? Key?
Yeah, that you want to put.
Why not this whole thing? Because we're trying to copy this whole thing. And so that will give us all the keys. It'll give us this whole object. So we can do it this way. Let's see if it works. That's cool, right? Oi. Brings me back nightmares of capybara. All right. This can take some other arguments. What else can it take? I think spread operator. Hugo?
So, what are the curly braces for in that?
These?
Yeah.
So the first argument of object.assign is where you're trying to write your properties into. We're trying to take this object Matt, and we're trying to put it into a brand new object. And that's what allows us to have a copy. Any arguments after here are any properties you want to add. So best practice is to have it inside of its own object. So if we wanted to give Matt some food, what should we feed Matt? Cookies. So this will add this thing into our object here on top of Matt being added in. So now our copy has food in it.
Can you just keep adding arguments? Like, is it like unlimited, or is it just the 3 spaces for it?
You can keep adding arguments as long as they're in an object. I've tried it without an object before, and it seems to break. So you can put this as a separate object, like if you wanted to overwrite his occupation here. You can do that. Or you can put stuff in the same object, like I also wanted to give him a drink. What does Matt like to drink? Is he a coffee or a tea drinker?
What was it?
Let's keep it PG. Let's make him a coffee drinker. I think that's pretty accurate. So now we have all this stuff inside of our mat object.
And can you delete, like, from the one that you're copying? Can you delete his personality using the object assign?
I don't think that's how object.assign works. I think you would have to make this a different object that doesn't have that property.
Can you reassign?
You can reassign. That's kind of what we're doing here because we're reassigning key.
So if you reassign a null, does it like delete it?
I think it, actually, yeah, you're probably right.
I don't know.
I'm not sure if this property will show up and be set to null, or if it just won't be there. I think it's going to show up and be set to null. Yeah. All right. There is a problem. It's a small problem. Well, it's actually kind of a big problem. Say that this was a nested object. So objects are complex data types, right? Right now, all of our values are primitive data types. They're just strings. What if we had a value in here, it's like mat array, and we set this to an array? So what kind of stuff should we put inside of mat's array? Huh? What?
You said blood oaths.
Oh, blood oaths. All right.
You like it.
Take it back.
I was taken aback. What else? Vampires. Put some vampires in here. All right, so now he has an array, right? Now we try to do this thing, and it's going to be the same result whether you use the spread operator or object.assign. Using object.assign or the spread operator only creates a shallow clone. So we're cloning this object. It's like a separate object from this one that we create, but this thing is not. So it's not going to get cloned. So object.assign and spread operator does not do a deep clone. It does a shallow clone. This is not one of those things that are like, I have to remember this detail. This is like, by the way. So if you look at Matt,
That's pretty important.
yeah, I mean, I personally haven't had to deal with it very frequently.
So you can't really clone a nested hash then, or a nested.
There are ways around it. So as you can see, these are two separate objects, but mat.matArray, if you check it against copy.matArray, see, it's already telling me it's going to be true. Which means if I push something into matArray, why is it giving? Okay. So then if you do copy.matArray, it also has it.
Wait, I thought it wouldn't. I'm so confused right now.
So object.assign is only a shallow clone.
Right. So you think it's not going to copy that nested array?
It doesn't create this as a truly separate array from the array inside of.
But it still shows up.
It shows up, but they point to the same reference. So it's kind of a problem. I mean, you can just go on Stack Overflow and be like, what is the most efficient way to deep clone an object in JavaScript? And you can read about it. So this is like your workaround. You can do something like json.parse JSON stringify, which basically turns your whole object into a string and then parses it back into an object, and then it'll be a deep clone. So that's like how you get around it. but I thought that I would bring it up just in case you do run into this issue, so things aren't breaking and you're not like completely confused.
Can you
Jordan?
object assign within an object assign? To do it?
I've done it with spread operators. I've never done it with object.assign because I think spread operators are a little bit more elegant. But yeah, if you had like an object here and you had some stuff in here, I think you can, let's find out. I think you can do this. No, I don't think it would work actually. Actually, maybe it will. Let's find out. I don't know. I don't know. I don't know anymore. I didn't prepare for this part of it.
Business, yeah.
I don't think this will work actually. I think what this would do is it would take all of these out and spread them out and put them inside of math. That's what I think this would do. I mean, you can look into how to do that, but that's beyond the scope of this lecture. It's just like an introduction to object.assign, and make sure you know what it is and how to use it. Now, moving on to higher order functions. So what are higher order functions? Like, what's special about functions? How can they be higher order? What does that even mean? I don't know, help. All right, yesterday we've seen, actually, there might be some answers for you here.
Doesn't it basically mean they can be assigned to a variable?
Kind of. Functions can return functions. And whatever it returns, when it's a function, you can assign that to a variable. So functions can return functions. What else? What makes them higher order? There's one we discussed, that functions can take in other functions as arguments. Anything else? Functions can do things like call other functions or create functions. So this is a cool thing that you can do in JavaScript. You can write a function, something like function runner, whose job is like, it takes an array of functions, and its job is just like to run all of those functions. So for example, I'm going to put all the results of calling it in here, and then you have 4.
You're saying we can't do that in Ruby?
I haven't really seen the idea of callbacks much in Ruby, because this implies that your array of functions will have functions in it that you're not actually calling. And they don't get called until you invoke this function. So you can do like, what would I push into my array? So I'm looping through an array of functions, and I want to invoke each one and push the result into my array. So what would I put inside my push? That's it? Exactly. Because this represents each thing in the array, and each thing in the array is a function, and you can invoke that thing, and then we can return results. So let's create 2 basic functions, like hello, that return hello, and like world, that returns world. How do we invoke this? How do we use our function running with those 2 functions that I created? So with an array of, look, it knows, it knows. I know, it's a little creepy. Sometimes secrets as an instructor, sometimes it's a little annoying because it gives the answers away. But yeah, like, that's pretty cool. I mean, I don't think you can do that in Ruby. I could be wrong. But I don't think in Ruby you can just do stuff like this where you put a function's name without it being invoked, and then it gets invoked later. And of course, we could rewrite this as a declarative kind of thing. If you wanted to, remember? Remember we did that here? And we did it in one line? Can we use a map? Gavin? Yeah, we can use a map. So let's use a map. Just so you get more exposure to this idea of declarative JavaScript. So what are we doing with each func? We're invoking it. Get rid of all this trash. Let's find out. I think this will work. And that like turned our long procedure of imperative JavaScript into declarative, just so you have like more exposure to it. Cool, it still works. So that's kind of stuff you can do. I'm gonna give you guys a short break, and then we're gonna get into closure. All right. I want to give the.
You go first. I was just gonna ask.
Yeah.
When you do something like that,
Yeah.
to like comment out and then do it under it.
That's what I'm doing now. I realized you guys might want to see that.
We look back later. It's not gonna make sense.
Yeah.
Isn't the function that you have all the way to the top a higher order function too?
This one?
Yeah.
Because it uses map?
Yeah.
Yeah. Map and filter and reduce, they're all higher order functions.
And the function and the callback is what you're using inside of the map, right?
Mm-hmm.
Okay.
Because map takes a function, so therefore map is a higher order function.
About functions.
I love functions. Good. So do you hear that, guys? Map, filter, reduce, they're all higher order functions.
So what makes something higher? Just more complicated.
A function that can call another function.
Oh, right.
So map actually takes a function as an argument. So that makes it a higher order functions. Gotta clean up that code. All right.
Your eyes still twitching?
Yeah, tengo como más de una.
Let's figure out how to stop.
What's up?
Apply warm compress to
You were looking at me.
Oh, no, so, was to make it a less sequencer. It's just like an algorithm. So, yeah, that's what this is, and then this is a way to find which one.
Oh no, it's on.
They
looked bored.
all these are also into this.
just keep
So yeah, so like I put in 1 million. And so like it's been up right. But and so I was trying to make it work, like see how high I could go without running out of memory. Which is
What is happening? I'm so confusing.
I'm just paying attention.
Go get your classmates. It's time to start.
it runs out of memory.
That's okay. We can start. Can't miss this.
Which is kind of already kind of like that.
Where is that? Who are we missing?
Yeah, but I already had to do that because I was running.
Yeah.
Oh boy.
Where's
It's
the
bounce back. So the way I do it is like I have an object and I'm just like for
No one
like little
I don't get this stuff from the
feedback.
You get down. Come back. Everyone's come back.
Tell him, Jay.
Quiet, Dan. Time on. Andy's. Oh, I thought you weren't even here to listen to me yell in Chinese.
yell in Chinese.
All right.
And then like this happens. This might break.
All right. I guess we're starting without him. So now we're gonna learn about closure, which is a common interview question. So it's good for you to have exposure to closure. One of my favorite jokes during this lecture. So anyways, in Ruby, we learned that things were related through like relationships and classes. But in JavaScript, things are more related through functions. So you don't even have true classes in JavaScript. When you write a class in JavaScript, it's pretty much like you're writing a function. Now with like the latest version of JavaScript in ES6, there is a class keyword, but it's what they call syntactic sugar. I personally think it's for people coming from other languages like Ruby who are used to classes, so they want to use the class keyword. They want to think that there's classes in JavaScript, but there aren't actually true classes in JavaScript. They're like functions under the hood. So for example, this is an example of like how you would write a class in JavaScript in like the older version without using the class keyword. Now there is such a thing as a class keyword, but just keep in mind that classes aren't really real in JavaScript. Gavin?
Are we gonna go over the this keyword?
We are going to go over the this keyword. For now, think of it as similar to self in Ruby. Okay, so basically things are related as functions in JavaScript. That's why functions can return other functions, and closure is around this idea. And it's important for you guys to like at least know a little bit about it, even though you won't necessarily be using it a whole ton, because employers absolutely love to ask this question because it touches on like a lot of ways that JavaScript works, and it can allow them to evaluate how well you know JavaScript. So as per the Flatiron way. We're gonna write some stuff that's not necessarily good code, not really closure yet, and then eventually we're gonna make it better and better, and we're gonna get to this concept of closure. So, first thing we're gonna do, we're gonna make a count variable. Already you're probably thinking, a global variable. Who uses those? Bad practice, right? I secretly still use them sometimes. Just don't tell anyone. All right, then we're gonna have a function. We're gonna call it apples. The idea is that you're gonna be selling apples, like you have a fruit stand. So every time you invoke this function, you sell an apple. So your count goes up. And we want to return something, right? Because it's JavaScript. You always got to return something. Do you guys know about string interpolation in JavaScript?
Yeah.
Template literals, as they're called? How do I do that?
Like this.
Backticks?
Yeah.
All right. I want to say something like, I've sold however many apples. So how do I specify how many I've sold?
Dollar symbol and code.
All right. So we're doing this. We can sell some apples. Let's see if we can invoke this. Comment this out. So if I write apples, what is it going to return? Okay. If I invoke it, what is it going to return? All right, cool. So we're selling apples. We're selling apples. This is great. This is kind of cool, right? I want to sell some pears. Does anyone like pears? I don't really like pears. I don't know why I use this example. Not my favorite. All right. So now, copied the same thing. I'm going to try to sell some pears. So what do I get if I write pears? To get a function. I'm trying to get you used to this idea that you can see a function without invoking it, right? What do I get if I type this?
You're gonna get the count.
Sorry. Cool. So now I'm selling pears. What if I try to sell apples?
Let's go ahead.
What am I going to see?
You're gonna see
The count.
5 apples.
Yeah.
Oh, no. But I want to keep them separate. What do I do?
You have to put the count as well.
Can't you just declare count inside of the function?
I can. So we're going to do that. We're going to do something interesting. We're going to return another function here. It can be an anonymous function, so I don't need to like give it a name or something. And that inner function is what's going to make my count go up. And it's what's going to tell me the apples that I'm selling, or however many. So, now what is apples? What's in that function? All of this, right? This is apples, right? What is apples invoked? What happened? What will I see if I type this? Now I'm invoking apples.
0.
Third function.
Who says string? Cat? Who says function? Okay. It is another function. So the way I like to think of it is every time you use your parentheses to invoke a function, expect to get back whatever is after the return. So I'm invoking apples right now. So when I invoke it, I'm getting back what it returns, and it returns this, which is another function. And what can we do with functions?
Invoke them.
We can invoke them. So how do I invoke this thing in here?
Double invocation.
Like this?
Yeah.
Yeah. Uh-oh. No. 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 How do I fix it?
So yeah, very
Closure. All right, when you Google closure, this is what you get. A closure is, yeah, something JavaScript is sexy. A closure is an inner function that has access to the outer enclosing function's variables, scope chain. The closure has 3 scope chains. It has access to its own scope. It has access to the outer function's variables, and it has access to global variables. So, the way I think of closure, you have some function. It does some stuff. Hello world. Remember how yesterday we talked about the Russian nesting dolls? We talked about the matryoshki. You can have like a global variable, like for apples, and it can be apples. And then you can have, inside of a function, you can have access to this, but if you create its own var apples and set it to bananas, this function will use this before using this, right? What if you throw in another function in here and have it return another function? And it has its own apples. Peaches. It actually has peaches. And it does some other stuff. So like now you have this scope chain where first it relies, this inner function will rely on its own apples. And since it's defined inside of another enclosing function, it also has access to this. And it has access to global variables. So that's what this is saying by like you have access to 3 different scopes. With closure, the key is this. You would invoke the outer function once to like, I think of it as initializing the variables in here. So then this inner function knows what these are. And you would invoke this outer function once. And then this inner function can be invoked as many times as you want. And it can keep incrementing. So that's what we're going to attempt to do. So pay attention to that diagram if you get lost. How can we tackle this? Given what we just saw. How can we translate it into this example where we invoke this function once, start off this count as 0, and now this inner function can be invoked as many times as you want? There's a concept we covered yesterday. Yes, Hugo?
I had a question. Is there, the one you did for apples and pears,
Mm-hmm.
is there a way to invoke pears without having to invoke apples?
There's no way to invoke this without invoking this, because the only way that you even have access to this function is through this return, and the only way you get something out that's in a return is to invoke the function that returns.
So if apples had a return, so it can't. Can the outer function have a return?
This is the outer function.
Right.
It has a return, but it returns an inner function. The inner function can have its own return.
Right, that's what I mean. Okay.
So we have to find a way to invoke this outer function once. Why? Because when we keep invoking both of them at the same time, we keep getting stuck with one. But by invoking just the outer one, we can start off our count as 0 and then keep going with our inner one and incrementing it. So does anyone have any ideas? Andy?
Oh, so it's resetting it to 0 every time, right? That's why we.
Mm-hmm. Because, yeah.
So you can just invoke that function right away.
How do I invoke it right away?
Wrap the whole thing in whatever you want and then add parentheses after. I mean the inner function.
The inner function?
Yeah.
So this thing?
Yeah.
And then invoke it?
Maybe.
How do I invoke that? Just one, right?
Yeah.
That doesn't help. Kat, do you know? So, is it the inner function that we want to invoke once? No. What happens if we put it outside? Yeah, exactly. We want to make our count go up. I don't think it's going to work if you do it here. I don't know what's going to happen, actually. But I don't think that's what we want. Yeah, it's not going to work for like other examples. So you're still going to have to invoke it twice. It's still doing the same thing. So, let's go back to what we had. What we want to do is invoke the outer function once. And we can do that with an if. So now, we've called this outer function once, and it set up this count as 0. The problem we had before is we were calling both of them at the same time, and it just starts the whole process over all of the time. We don't want to start the whole process over every time. We want to start this process just once, and then this inner part can make this count go up without resetting it every single time. So this is a concept from yesterday. This whole ify thing, immediately invoked function. So now we've invoked our apples function as we've defined it. So what does apples give us now? What will I see if I type apples?
Inner function.
Why?
It invokes the first one.
Yeah, because apples is already set to the invoked version of this. And the invoked version of this is this inner function. So now apples is this inner function. So now, what is apples invoked? What does that give us? What happens if I do it again? It works. So now it's actually going up. And it's because of this idea of closure.
So now there's no way to do the outer function by itself.
Because you've already set apples to the result of this function. You've already invoked it. So now apples is set to just this function. And this inner function, that's like the idea of closure, is it remembers the variables from its outer scope. So it remembers what count is. So now every time you invoke this inner function, it knows that it came from here, from inside here. And it knows that count was 0, it incremented count. And count changed to 1, and then if you invoke it again, it remembers count was 1 and it changes it to 2. And we can do the same thing with pairs. So, for instance, we can do this. So how would I invoke pairs?
Pairs with the invocation.
What about apples? What is apples going to be? So now we don't have the problem of them sharing a variable. But here comes my second joke. This iffiness thing is kind of iffy. I think this whole I don't like this whole iffy thing. I have found that it's very rare that you actually need to use iffies. I personally find that it's kind of confusing to use iffies. So I think there's an easier way to do this. So let's go back to what we had.
But still, you're gonna still have a closure?
Not yet. We're about to make this into a closure. So we want to get this inner function. We want to invoke this outer function once. So we can make a variable, something like apple seller, that's set to this return. So how do I do that?
Copy paste.
Double.
I want just this.
Apples with 2 parentheses.
Exactly. Because when I invoke a function, I get what it returns. And it returns this function. So now apple seller is a variable, because we can do this in JavaScript, that's set to this function being invoked, which is another function. And what can you do with functions in JavaScript? You can invoke them, you can call them, exactly. So since this variable is actually a function, we can invoke this variable. So this kind of allows us to create a closure in a more elegant way without wrapping everything in an iffy. Because now we've called this function once, right here, when we created this variable, and now we can call this variable as many times as we want. So, what is apples? What is apples? What is that going to give me? This thing is apples. What is apple seller going to give me? Which is? So this thing, string or something else? Or not invoked, it's going to be, oh no. There we go. And what is apple seller invoked? There we go. So now we can increment this. We can do the same thing with pairs if we wanted to.
Wait, why did we want to do that? Why did we want to set the function variable?
This part?
Yeah.
So what we're trying to achieve is we want to call this outer function once, so it can kick off this variable, count, to 0. And then this inner function will remember count was 0, and then it can increment it to 1. Next time we call the inner function again, it'll remember count was 1, and it'll increment it to 2. We're not resetting count every single time, because we've called this thing just once. If we called this outer function more than once, it would reset count every single time. So now this inner function can increment count, right? So over here, by invoking apples just once and saving it to this variable, we've invoked this outer function just once. And now we can invoke the inner function. And the inner function is now apple seller, because the inner function is this. We can invoke this as many times as we want. So, how would we achieve the same thing with pairs? How would we use a variable instead of an iffy here? Exactly. And then do what? Exactly. And set it equal to? Exactly. So now, we're selling pairs, and we're selling apples. But this code is not very dry. Is there a way where we can just write one function that will work for any fruit?
Fruits with constant fruits.
So I'll make it a new thing. just so you guys can hold on to this. So let's make one called fruit stand. So now I can truly sell any fruit. Does it need an argument? We want to be able to use it for any fruit. All right, so let's give it an argument of fruit. And then what should I put in here?
What do you want it to return? Do you want just like to say the fruit, or do you want to say like this many pears and this many apples?
I want it to tell me the fruit that I've sold. So I want to be able to invoke a function like coconuts, and every time I invoke that function, it raises my number of coconuts. Ruby?
Interpolate where 10 pears, just interpolated fruit.
Exactly. Okay. So now, what kind of fruit should I sell? Bananas. Okay. What should I set this to? I want to invoke this thing. Yeah, so fruit stand. And it takes an argument, right? Oh, I misspelled this. This is sand. What's the fruit that I'm selling, guys? Bananas! You want some coconuts? Let's sell some coconuts.
So do parameters work the same way as variables?
Can you clarify your question?
Like, I was just wondering how it has access to fruit and it's a parameter. I'm guessing it's like the same thing as a variable. That inner function, how it has access to the fruits parameter.
This or this?
Right. It'll answer my question.
Okay.
Yeah.
Let's do one more. Someone give me a fruit to sell.
Mango.
Mangoes. Is this right or is this right?
Yeah, mango.
That's Spanish.
Mangoes. Okay. All right. So, coconuts. Now I'm selling coconuts. Cool. Mangoes. Now I'm selling mangoes. Very cool. Bananas. So now this thing is reusable. That's pretty cool, right? You know what I did during the first mod with your class? I built this thing. Remember? Random student presents?
Yes.
I used closure. Here, I made a function, pick students, that returned another function, and it used this array, and every time it made the array smaller and smaller. So it's kind of like the same idea. Calling the outer function once, pick students, and then the inner function as many times as you want, and it keeps changing this like variable that it closes over. So it kept changing this array variable. Kind of like here, we kept changing our count. How do you guys feel about closure? It's a really difficult concept to grasp, and it's not something you're gonna have to like be able to do on the fly, but it's good to have exposure to closure. Yeah.
So when you say closure, is that like the verb, or is that the inner function, or is that the whole thing?
It's the whole thing.
So it's like the function itself, or what?
It's like the idea that an inner function can remember variables from its outer function scope and be able to play around with them, change them. So that's why like this whole definition, it talked about the whole thing, about how like an inner function has access to 3 scopes.
Closure is an inner function? So it's the inner function, no?
It's a function and it's variables that has access to.
I think it's like the whole thing, because then it says the closure has 3 scope chains. So it's like the whole closure itself.
Not that the inner function has 3 scope chains?
You can think of it as the closure being the inner function, but in order to explain closure, you would have to explain how there's an outer function involved and all of the scope chains involved.
Okay.
So I would still think of it as like everything to do with closure. All right. So, should we do some DOM manipulation? We'll do just a little bit. I'm going to comment this out for now. You can look at this code later. Who can remind me about the event listener we used yesterday to make sure everything is loaded on the page? Mm-hmm. Ayo. Okay, so what does the first variable represent? Yeah. And I'm only torturing you guys this way so that when you have your lecture tomorrow about manipulating the DOM, you're not completely lost. Because manipulating the DOM can feel like a completely different language from just vanilla JavaScript. So, what's the second argument for add event listener? All right. So we're going to do some stuff to our DOM today. My idea is to have a bunch of li variables, maybe, or not variables, li elements, and maybe change their color. So we have this, right? I'm just going to make a ton of them. And I really mean a ton. Yeah. Okay, that's enough. So now we have them here, right? How do I grab all of these? Mm-hmm. So let's name the thing that we're trying to grab. Let's name them elements. How do I grab all of these li elements? And then?
You have to use a hashtag?
I don't think you do in this case because it's not an ID. So with tags, if you're using query selector, oh, we want all of them. You just put in quotes the tag that you're looking for. If you're looking for a specific class or ID, if it's a class, you put a period in front. And if it's an ID, you would put the hashtag. All right. Let's see what this gets us. All right. So we've grabbed all this stuff. Is this an array? What is this? It's an array-like object. My favorite kind of object. All right, cool. So now I want to change the color of every single one of these.
Wait, sorry, why is it not an array?
Who knows? It's JavaScript. But we can confirm that it's not an array by doing array.isArray and give it this thing. It tells us false. If you look at it, it says node list. It's something that came from the DOM, so I guess things that come from the DOM are not necessarily arrays.
So if you do type of, what would you get?
So type of doesn't work on arrays, because if you give a real array to type of, you get object. So the only way to check that something is an array, you do array.isArray. And it's telling me false. But maybe that's okay.
So instead of node list, it would say array?
Mm-hmm.
Okay.
Yeah, but you can still check here to see what kind of method you can run on it. So you can't run every single array method on this thing because it's not a true array, but for instance, you can run a for each on it, which is kind of cool. Okay, so if I want to change the color of one of these, there's actually, I think there's a style property on this thing. And then that style property has color. So right now it's blank. So for example, if we want to just capture one element, how do we do that? Very similar to this. Oh, too long. Very similar to this.
Just do a deal. Query selector. Am I?
Exactly. Yeah, so this will just give you the first thing, right? So if we want to change the color, we can do style, color. What color should we make it?
Pink.
Pink. That's pretty cool. So this is like the kind of stuff that you'll be doing. So why don't we put some stuff in here? Why don't we grab all of our elements in here? How do we grab all of those li elements?
The way that
What do you think I need to do if I want to impact every single one of them and change its color? Yeah, so we can do for each. What does for each take? It takes a function? Cool. What does that function take? An element? Cool. What do we want to do to each element? What did we do in the browser just now? How do we do that? Exactly. Will this work? That's exactly only one way to find out. There we go. That's kind of cool, right? But they're all the same color. Like, what if we wanted to randomize some stuff? How do you randomize stuff in JavaScript?
Number from 0 to 256.
Okay. So, what do you want to call that thing? Actually, let's use a let. All right, random color. How do we use math.random?
Wait, it's going to be a problem.
Why? It'll be fine. We'll interpolate it. How do I get a random number from 1 to 256 or from 0 to 256?
When you do math.random, doesn't it give you a random number from 0 to 1?
It does.
So then we usually need to do math.random and math.floor and then times.
Well, your times would be how many numbers you're looking for. So we don't want 0 to 1. We want 0 to 256. So like you would times it by however many numbers you want, right? So we want 256. What is the math.floor for? Yeah, this is so we can get integers instead of like decimal points. Because math.random just gives you a huge decimal between 0 and 1. Timesing it by 256 will give you random numbers between 0 and 256, but they're going to have like decimals in them. So math.floor like lowers it to that lowest integer without the decimals. So that's how you can use this. That's kind of cool. So should we randomize things? We can use RGB. Have you guys used that for colors? Okay. So I can actually interpolate this now, this thing. How do I do that? And then? What should we give for the other ones? Let's try 0, 0 for now and see what happens. They're all the same color. Why? So we're never actually changing this to another random number. We're picking a random number, and for every single element, we're applying that random number. So we can reassign this, right? We can reassign it to another random color. So now, every time this runs for one element, it's gonna have a random color, and then it's gonna reassign that random color so that the next element can get some other random color. So now there's a little bit of stuff going on. If you want to make this cooler, I suppose we can have all 3 colors be random. This is a little more sloppy, but you can have like random color 2 and random color 3. Fun things you can do with JavaScript. And then you can just reassign all of them. So let's see if this gives us a truly random result. There you go. So this is like fun stuff that you can do with the DOM that you'll be doing with more. I want to show you guys a funny video. Are you ready? You've seen this one? It's pretty good.
No. All right, good. You guys know what WAT means? WAT. Exactly, exactly. Let's talk about Ruby. In Ruby, if you reference an undefined variable, of course it name errors, as you would expect. And if you try to assign B to A with them undefined, of course it name errors, as you would expect. And what happens if you try to assign A to A with A undefined? Nil. Correct. Nil. WAT. Let's talk about Ruby. Ruby, unlike some other dynamic languages, does not have bare words, so you cannot just type words in and have strings come out, unless you define a particular method missing that does the right thing. And then if you type bare words, suddenly Ruby supports bare words. And in fact, it will even support bare words with bangs in them. And this is not deserving of WAT. This is actually a result of how awesome Ruby is. But if you ever actually do this, then WAT. Let's talk about JavaScript. Does anyone know in JavaScript what array plus array is? Well, let me ask you this first. What should array plus array be? Empty array. I would also accept type error. That is not what array plus array is. Wrong. Wrong. Array plus array is empty string. Obviously, I think that's obvious to everyone. Now, what would array plus object be? This should obviously be type error because those are completely disparate types. Does anyone know what this is? No. Close. No. Far away. It's object. Right. Nicely done. Now, of course, because this is plus, so you can flip the operands and the same thing comes out. So if we do, what? No, that's just an object. If you do object plus array, you should get exactly the same thing, which, as you can see, you do. And finally, the only one of these that's actually true is, because you add arrays, you get empty string, that doesn't make sense. But an object plus an object is actually not a number, technically. So this one's actually right. And exactly, right? Like, what is even going on in this lab? I don't even understand what person with a brain in their head would think that any of this is a good idea. Okay. Enough making fun of languages that suck. Let's talk about JavaScript. If I say array.new 16, or just array 16, I get an array of 16 things, which it represents as 16 commas, which is obvious. And if I then join those with a string, then I get the string 16 times. This is actually the only line in this entire presentation that's reasonable. Now, if I take that string and then add a 1 to it, it interprets the 1 as, or casts the 1 to a string, and then we get wat1 a bunch of times. Fine. Does anyone know what will happen if I subtract 1 from the string? I'm assuming no one does. I'll give you a hint. Does this help? Does anyone know? Plant man.
Who knows? It's JavaScript. All right, go have lunch.